There are secrets across the entire universe, from right here in our solar system's backyard to the furthest reaches of the cosmic ocean. It has been like that since the beginning. Ancient astronomers were perplexed by the nature of comets and puzzled over the chemical explosions of stars, and both of these topics occupied their minds for many centuries. These ancient puzzles have been answered, but as larger telescopes and more sensitive sensors view farther into space, new mysteries have arisen to take their place. Welcome back to another video. Today we'll look at a new strange mystery discovered in space by scientists. But first, we are giving away $100 to one of our lucky subscribers. All you have to do is watch the entire video, leave a comment with your greatest takeaway, like, share, and subscribe. So, without further ado, let's get into it. Now, we all know that the universe is a mysterious place. There's no doubt about that. Recent advancements in technology, such as telescopes Hubble and James Webb, have further driven our curiosity. So, in this video, let's talk about this new discovery that completely baffles the minds of scientists at NASA. Scientists investigating our cosmos with the most cutting-edge telescopes on the planet uncover new secrets concealed inside its depths. A recent discovery in outer space is not an exception to this rule. These spectral rings of radio emissions were previously referred to as odd radio circles. Their discovery is relatively new, and their sightings are pretty uncommon. In the beginning, when astronomers were looking for radio-transmitting objects in the sky, they found 3 of these odd circles. Only 2 further observations of the occurrence were added to that number after it had already been compiled. After being discovered for the first time by the radio telescope ESCAP, or the Australian Square Kilometre Array Pathfinder, owned and run by the Australian government's Department of Science and Technology, 0 odd radio circles became subjects of intrigue almost immediately. There were many different hypotheses as to what generated them, ranging from the throats of wormholes to cosmic shock waves. Researchers now have access to more information, which is assisting them in narrowing down the range of possible explanations thanks to a newly detailed image obtained by the Meerkat radio telescope at the South African Radio Astronomy Observatories. There are now 3 primary hypotheses that attempt to explain the origin of ORCs. First, it is possible that they are the relics of a cataclysmic explosion that occurred in the heart of their host galaxy, such as the collision of 2 highly enormous black holes. Second, it's possible that they're strong jets of energetic particles shooting out from the core of the galaxy. Third, they might be the consequence of a starburst termination shock that occurred as a consequence of the formation of stars in the galaxy. A much closer look. Amazing photographs of one of these rings were captured with the Meerkat radio telescope in South Africa, displaying the ORC in extraordinary clarity. There is a faint radio emission spot in the center of the ring that Meerkat has determined to be associated with a distant galaxy. It is now widely accepted that this galaxy was the source of the odd radio circles. These center galaxies are visible to us in several other ORCs, all located at an incredible distance from Earth. We now believe that these rings are found around distant galaxies around 1 billion light-years away. If this is the case, the rings must be pretty large, approximately 1 million light-years. The rings represent the borders of a spherical shell around the galaxy, like a blast wave from a big explosion in the galaxy, according to the modeling of the feeble hazy radio emission that Meerkat finds within the rings. The sphere looks brighter towards the borders, where there is more material along the line of sight, similar to a soap bubble. This gives the impression that the objects are rings rather than orbs. A lot of energetic electrons' magnetic field information may be obtained by mapping the polarization of radio waves, which is done by Meerkat. The polarization demonstrates a magnetic field that runs along the rim of the sphere. This points to an explosion occurring in the center of the galaxy, resulting in a hot blast colliding with the tenuous gas located on the galaxy's periphery. As a result, the shock wave produced electrified electrons in the gas, which caused the electrons to spiral around the magnetic field and produce radio waves. The discovery by Meerkat that there are numerous curving filaments of radio emission contained within the ring came as a significant and pleasant surprise. Yet we are still not sure what these things are. On the other hand, we know that the sphere is so enormous that it has absorbed other galaxies as it has expanded outward from the primary galaxy. The filaments may be trails of gas torn from the galaxies by the shock wave that's moving through. New questions to answer. So, what are we to make of it all? We don't know for sure, as is the case with the vast majority of radio astronomy. New data and information have been added to the enigma, and some indications have been supplied. Not having specific answers may strike some as irritating. However, this is inherent in certain branches of scientific inquiry. The SKA, which is scheduled to become operational within the next decade, will explore faint, uncommon, and enigmatic objects even more thoroughly, which is thrilling because there is more to come. As we have seen throughout the history of science, and as we are currently witnessing with ORCs, this almost ensures the discovery of the unexpected. The findings in the far future may appear dim, but the possibilities provide a picture of a bright future. To this day, researchers have only been successful in locating ORCs through radio telescopes. When they used optical, infrared, or X-ray telescopes, they could not find any traces of them. The diameter of the rings is around 1 million light-years, which is 16 times more than the size of our own galaxy. Despite this, it is difficult to spot any strange radio circles. According to one of the authors of the report, Professor Ray Norris from Western Sydney University in Cairo, only 5 unusual radio circles have ever been disclosed in space. Professor Norris added that although we know that ORCs are rings of feeble radio emissions encircling a galaxy with a very active black hole at its center, we do not yet understand what generates them or why they are so rare. The development of an understanding of odd radio circles is allowed by collaborating with these complementary telescopes, ESCAP and MEERKAT. These telescopes are working together to identify and explain these objects as rapidly and effectively as possible. Collaboration on a global scale, in terms of the teams of individuals working on an astronomical project and the technology at their disposal, almost always results in improvements. Access to radio telescopes that are even more sensitive than those used by the SKA Observatory, which is funded by more than a dozen countries, including the United Kingdom, Australia, South Africa, France, Canada, China, and India, is required for scientists if they are to fully comprehend the phenomenon of odd radio circles. Once constructed, the new telescopes will discover a great deal more ORCs and be able to provide us with more information regarding the life cycle of galaxies. However, as we wait for the SKA to become fully operational, ESCAP and MEERKAT will speed up the rate at which we can change our understanding of the cosmos. The data for other ORCs that have already been targeted with MEERKAT is now being processed. There is a good chance that other ORCs are concealed in the data collected by other radio telescopes that have enormous fields of view, such as the Giant Meter Wave Radio Telescope (GMRT) in India and the Low Frequency Array (LOFAR) in the Netherlands. Both of these telescopes are located in their respective countries. In addition to gathering more data, scientists are also creating machine learning techniques to make it simpler to look for faint blobs in enormous radio pictures. This is being done in tandem with the collection of additional observations. To this day, however, the ability of human eyes to detect ORCs remains unrivaled. Do you think we will be able to figure out the real cause of these ORCs? What are your thoughts? Share them in the comments section below. And that's it for this video. If you're new to this channel, make sure to hit the like, subscribe and notification buttons for more videos like this. As always, thanks for watching and see you next time.